I'm Anil Kumar. Welcome to my series on vectors. Let me thank my students to share their test paper with me and let me congratulate them to get more than 90% marks. Here is a very recent test on vectors in which we are going to discuss about lines. We'll talk about intersection of lines, finding angles, parallel perpendicular lines, finding distance from a point to a line, and area of triangle. We'll also have questions relating to displacement and velocity. There are about 11 questions in this test paper. We are going to solve them one by one. So let me share these questions first with you. You can always pause the video, copy these questions, try them out, and then we'll look into their solutions, right? First few questions are short answer type, which you can copy. So here you need to find vector equation from different conditions. And then we are given an equation, you need to find its direction and normal vector. Question number 4, we need to figure out how many points of intersection will be there for these two lines without solving. So these are concept-based questions, right? So once you have all these concepts, then we'll get into more details. We'll now talk about velocity and speed, right? Application questions. Now we'll have equations of line given 2 points, and then for different conditions, we'll find scalar equation of line, and then we'll have equation based on the velocity vector parallel to a given vector. Question number 9 is to find the shortest distance from a point to the given line. Question number 10. Now it has many parts, so we'll work in details how to work with two perpendicular lines, finding angle between lines, right? Intersection of points, like that. And also, question number 11 is more detailed question where we'll have 5 different parts. So we'll talk about line passing through a given point, find its vector equation, another line, right, perpendicular one, and then similar conditions, also finding a point at a given distance. So you can actually pause the video, copy these questions, solve, and then look into their solutions. Now let us take solution of these questions. Question number 1. For the line r equals to 8 minus 1 plus t 4 comma 3, write down the parametric equation, write the Cartesian equation. Does the point 0 minus 7 lie on the line? So to convert to parametric equation, we have to write x and y in terms of t. T is the parameter, right? So from here, we can straight away write x is equal to 8 plus 4t and y is equal to minus 1 plus 3t. Part B, write the Cartesian equation. Now to get the Cartesian equation, what we could do is we could write this vector equation in the form of symmetric, right? So let's do this solution here. So we could write this, the point is 8 minus 1. So in symmetric form, we get x minus 8 over the direction 4 equals to y minus minus 1 over 3. Now we can cross multiply, so we get 3 times x minus 8 equals to 4 times y plus 1. Let's apply distributive property. So we get 3x minus 24 equals to 4y plus 4. Bringing them together, we get 3x minus 4y minus 24 minus 4 equals to 0. And we get our Cartesian equation as 3x minus 4y minus 28 equals to 0. Okay. So that is the solution for part B. Let me rewrite here. 3x minus 4y minus 28 equals to 0. The third question here, part C, is does the point 0 minus 7 lie on the line? Now to test this, what we can do is, in the Cartesian equation, we can place 0 and minus 7 and see if the equation is satisfied. So let's test the point P, which is 0 minus 7, using this particular equation, right? So we'll substitute for x 0, for y minus 7. So we get 3 times 0 minus 4 times minus 7 minus 28, right? So we get 0, minus and minus becomes plus 28 and minus 28. So this is equal to 0, right? So minus 28 plus 28 is also 0. So 0 equals to 0. So we get our solution. Yes, it does. Yes, it lies on the line. Perfect. So I hope all the 3-part solution is perfect. Let's move on to question number 2. Find the vector equation for each of the following lines. So last time we worked with the vector equation and got all others. Now we are doing the other way. Parallel to z-axis and through this point. So vector equation are, which we could also write as xy is equal to, we are given the point, so let's use this particular point, minus 2, 5, 6, and z-axis, parallel to z-axis, that is to say, we'll use a parameter, right, and it is only moving along the z-axis, so we have 0, 0, and 1, okay? So that's how you could write. Perpendicular to this given line and through the point 4, 7. Now that is the normal given to us. So from here, we know that normal vector is basically equal to 4 minus 3. So we could use normal vector for perpendicular, correct? And therefore, the line becomes R. You could also write this as R equals to, in this form, right? So there are different forms in which we could write the equation. So 4, 7 plus t times any parameter could be used, right, for perpendicular. So we use the normal vector as such, 4 minus 3. Clear? Part C is through the point this. So when we have to write through a point, we need to find the direction vector. So let's say the direction vector D is we could write 2 minus 1 minus 2 minus 3 and 5 minus 1, right? So that gives you the direction vector as 1 minus 5 and 4. So once you get the direction vector, then you could easily write the vector equation R as equal to the given point, any one of them, 1, 3, 1 plus any parameter, let's say S this time, and the direction vector 1 minus 5, 4. So we have used different conventions in answering this question. Now all over the world, all these different conventions are being used, and since these videos are being watched globally, so I thought let me mix them up, right? Question number 3. Given 3x minus 2y equals to 12, state normal vector of the line. So this is the normal vector, 3 and minus 2. So the normal vector here is 3 minus 2. The direction vector of the line. So the direction vector of this line will be, flip it, right? So you could just flip it and change one sign. So it becomes the direction vector. Perfect. Now, for you, a question. The question here is, write a vector equation and a symmetric equation of this line. Perfect. So that is the question, practice question for you. Now, with those question number 1, 2, and 3, you should be in a position to answer this. Now, let's move on and take up question number 4. Without solving, determine the number of solutions of each system. Now, how can you do this? We have been given two systems, okay. Let's look into the first one. xy is minus 1, 22 plus s minus 1, 3. And xy is 5, 4, t, 3 minus 9. Now you can see it's a multiple. So these lines are definitely parallel, but we are not sure whether they are coincident or parallel, correct? So to check this, we should actually rewrite this equation in symmetric form. So I could write this. This is the point given to us. So we could write this as x plus 1 over minus 1 equals to y minus 22 over 3. Correct? Now if I cross multiply, then I get 3 times x plus 1 equal to minus y minus 22. Let me take it to the left side. So if I take it to the left side and open this bracket, I get 3x plus 3, and here I get plus y minus 22 equals to 0, and that is 3x plus y minus 22 take away 3 will be 18, 19, right? So minus 19 equals to 0. So this becomes your equation of the first line, correct? So we say this line. Now since we know that the directions are same, correct? Scalar multiple. So it is, you can see, minus 3 times minus 1, 3. So we know they are parallel. That is what we get. Now we have to only check if 5, 4 is on this line or not, correct? So if I substitute 5, 4, what happens? So 5 for x, so 3 times 5 plus 4 here, right? Minus 19 equals to 0. It does gives us 0 equals to 0. So the point lies, right? So that means the point, this point, 5, 4 lies on line L1, right? So this is line L1, this is line L2. So we have just shown that the point 5, 4 lies on L1. That means they are coincident. Okay, so that means they are coincident. Perfect. Since they are coincident, how many solutions do we have? We have infinite solutions. So we have infinite solutions here, right? We have to find the number of solutions. So I hope this point is clear, right? Now you can actually pause the video and answer the second one, right? So it is 2x minus y equals to minus 4, and we have minus 12x plus 6y equals to 18. Correct? Now let's look into it. So if I start with the equation 2x minus y equals to minus 4, and if I multiply all this, we are looking for minus 12 here, right? So if I multiply by minus 6, what do I get? Well, if I multiply by minus 6, I get minus 12x plus 6y equals to plus 24. Correct? So what we see here is that the normals are same. They have same normal. We can say same direction. However, this point is not matching, correct? They are not matching, right? So they are not matching. In that case, these lines are parallel lines. Is that clear? So we'll have 0 points of intersection or zero solutions, correct? So that is how you could actually answer this question. I hope this concept is absolutely clear. So we are actually not solving, we are not trying to find the points, but we are just seeing first, are there directions scalar multiples? So that is first test, scalar multiple direction. And the second one is, does the point lie on the other line? Right? So in the first case, the point lies on the other line, so they are coincident. In the second case, we have different y and x intercepts, so they are parallel. Clear? Question number 5. A particle at P moves such that x of t equals to 5 plus t and y of t equals to minus 2 minus 3t, where t is greater than or equal to 0 and t is in seconds. Determine initial position, position p after 3 seconds, velocity vector of p, and speed of p in meters per second. So that is application of velocity. You can always pause and answer the question. Now initial position means that t equals to 0. Okay? So we'll just substitute t equals to 0 here and get our answer. Clear? So if I write x0, we get the value 5, and for y0, we get the value minus 2. And therefore, you could write the position of P as, you can say OP, position vector, okay, as equal to 5 minus 2. Correct? Next, position of P after 3 seconds. So this time, we'll substitute 3 here. So we'll find what is x of 3 equals to. So which is 5 plus 3, which is 8. And y of 3 equals to minus 2 minus 3 times 3, which is minus 9, and minus 2 minus 11. And therefore, this position is equal to 8 minus 11. Clear? What is the velocity vector? Now, in such equations, the velocity vector is the slope, rate of change. Do you see that? So, velocity vector, so we remember this. Velocity is rate of change. So, in this case, the velocity vector is basically 1 and minus 3, right? So, 1 minus 3 is your velocity vector. Perfect. What's the speed? Now speed is magnitude, correct? Speed is magnitude of velocity, correct? So the magnitude here is square root of 1 square plus minus 3 square, which is equal to square root of 10. And the units meters per second. Perfect. So that is how you're going to answer this question. So I hope that is absolutely clear. Let's move on and take up question number 6 now. Question number 6. Determine the symmetric equation of the line joining points A and B. So let's get the direction AB first. So the direction from A to B will be, we will do this formula. So 15 minus 3, 1 minus minus 2, minus 11, minus 4, correct? So that is the direction vector, which is 12, 3, and minus 15, correct? So we know the direction vector, we can use any one point to write the symmetric equation. So now the symmetric equation will be we can write this as using point A. We'll use point A, right, which is 3 minus 2 and 4. So it is x minus 3 over 12 equal to y minus minus 2, makes it plus 2 over 3 equals to z minus 4 over minus 15. Correct? So that becomes the symmetric equation for the given line. So these questions are straightforward. They should not take much time. Question number 7. Determine the scalar equation of the line with normal vector 3 minus 2 and through this point. Correct? So when we are given the normal vector, so we are given normal vector as 3 minus 2, and we are given a point which is 1, 6. So the Cartesian equation or the scalar equation, they are the same thing. So what is the scalar equation? It is of the form of ax plus by plus c equals to 0, where the value of a and b, right, is the normal vector, which in this case is 3 minus 2, correct? So we know this value. So we can just write this as 3x minus 2y plus c equals to 0. Now we know the point. So now we know the point, which is minus 1, 6. Substitute the point, right? So we get 3 times minus 1 minus 2 times 6 plus c equals to 0, which is minus 3 minus 12 plus c equals to 0, or c equals to minus 3 minus 12 is minus 15, taking on that side becomes plus 50, correct? So we get our answer that the scalar equation should be 3x minus 2y plus 15 equals to 0. Is that clear? So that is how we can actually find the scalar equation. Perfect. Question number 8. Determine the velocity vector of an airplane moving parallel to minus 3i plus 4j with a speed of 75 kilometers. So here we are given the magnitude of our velocity vector, which is 75, correct? We are also given direction, so it is the direction of 3i plus 4j. So the direction here is minus 3 and 4. Now we want a vector with magnitude of 75 in this particular direction. So what should we do? We need to find unit vector in this direction. Do you understand? So to find the unit vector in this direction, normally we write with this kind of a symbol on the top. We have to divide this by its magnitude, correct? So that will be minus 3, 4 divided by its magnitude, which is minus 3 square plus 4 square. Right, so we get minus 3, 4, and this is 25 square root, which is 5. So the direction vector is basically minus 3, you can write 5 here, 1 over 5. Since we have to, simplify, we could do that. So we could actually multiply by 75 and get a simpler form. So we'll use like this. So that becomes the direction vector, okay? So the velocity vector for us, we want magnitude of 75. This is unit vector, right? So that is going to be the unit vector into the magnitude. So which is equal to 1/5 of 75 times the direction is 3, 4, right? So kind of I've taken this liberty to write like this so that it's simpler, that's all. So we'll just divide, and then it goes 1, 25 is 15, the multiply inside and get your answer. So the velocity vector is minus 45, 60. Do you see that? So that becomes the velocity vector in the given situation. I hope the steps are clear. You could have done the other way also, which is normal. You could write like this. And then multiply this by 75 to get your result, right? So you could do like this also. One and the same thing. Times 75, correct? Question number 9. Calculate the shortest distance from the point A, 359, to the line R, 2i minus j minus 4k plus t, 3i plus 2j plus k. Now to find the shortest distance, you should remember that if this is the line, let's say L1, in that case, we are looking for a perpendicular from A to the line, right? So from A, we are looking for a perpendicular. Correct? So that is the concept. This is the point A, 3, 5, 9. Let's say the point on the line is R, so that AR is perpendicular to the line. Correct? So in that case, the dot product of AR with the direction of the line, which we can also call M, right, should be equal to 0. Perfect. Now what is AR and what is M? M, that is direction of the line, can be seen from here, right? So that is M. And any point R on this particular line, so this is the point on R. Is that clear? So from A to R, it is going to be the point R, 2 plus 3t minus A, which is 3, minus 1 plus 2t minus 5 and minus 4 plus t minus 9. That is AR dot M, which is 3, 2, 1. This should equal to 0. Correct? So let's write down what AR is. Simplify this. So we get 3t minus 1, 2t minus 6, t minus 13 dot 3, 2, 1 should be equal to 0. Clear? So that is how we can actually find the dot product and get our answer. Okay. So let's find the dot product. So we have 3 times 3t minus 1 plus 2 times 2t minus 6 plus t minus 13 equals to 0. That gives us 3t minus 3 plus 4t minus 12. Let me write here, plus t minus 13 equals to 0, right? So combine these terms. We have 3 plus 4, 7 and 1, 8t. And all these negative numbers. Minus 3 minus 12 is 15. So we have 28. Oh, we missed, this was 3t, I'm sorry. This was 3t, because otherwise we are getting fractions here. So this is 9. Okay, so let me redo this. That is better. So 3 times 3t, basically. 3 times 3t minus 1 plus 2 times 2t minus 6 plus t minus 13 equals to 0. Correct? So 3 times 3 is 9. Minus 3 plus 4t minus 12 plus t minus 13 equals to 0. 9 plus 4, 13, 13 plus 1, 14. So we get 14t minus 15 and 13, 28 equals to 0. So that gives you that 14t equals to 28 and the value of t is equal to 28 divided by 14, which is 2. Correct? So we get the value of t as 2. We can substitute this value here. So t equals to 2. So what is AR equals to? So AR is actually the distance also. So from AR we can actually find the distance, right? So AR is equal to, substituting 2, here we get 3 times 2 minus 1, 2 times 2 minus 6, and 2 minus 13, which is equal to 5 minus 2, and this is minus 11, correct? So the magnitude of AR is the distance, which is square root of 5 square plus minus 2 square plus minus 11 square, correct? Now we can use calculator to find this answer. So we have square root of 5 square plus 4, we can write, plus 121 is equal to 5 square root 6. So that is the exact value of this particular answer. There's so many units. So I hope it is absolutely clear. The idea is you have to find a point R on the line so that AR is perpendicular to the line given to you, right? So this is the line R given to you. Once you have the point R, you can find distance using distance formula. Perfect. Now let's move on and take question number 10. Given the line L1, x minus 7 over 2 equals to y minus 2 equals to z plus 6 divided by minus 3, and L2, which is x is 3 plus s, y is 9 plus 5s, z is 13 plus 5s, show that line L1 and L2 are not perpendicular. Okay, so to show that they are not perpendicular, we have to basically find the dot product. It should not be 0. Correct? So let's do part A. So the dot product, the direction vectors are what? Let's write down here. So direction vector for M1 is 2, 1, minus 3. And direction vector for M2 is 1, 5, 5. Correct? So let's find dot product of M1 and M2. It is equal to 2, 1 minus 3 dot 1, 5, 5, which is 2 times 1 is 2 plus 5 minus 15, right? So that is minus 10 and minus 8. Since it is not equal to 0, they are not perpendicular. Okay, so we can write down M1 dot M2 is not equal to 0, therefore not perpendicular. So part A is done. Part B is to find the acute angle between the two lines B. So we could use dot product to find acute angle, right? So we'll do that. So acute angle is, we know M1 dot M2 will be equals to magnitude of M1 times magnitude of M2 times cosine of theta, right? So that gives you cos theta as equal to the dot product of these two directions divided by their magnitudes. Correct? So that should give us the angle. So from here, let me write down here, cos theta equals to dot product we calculated as minus 8. So this is the dot product, minus 8. We can write here minus 8 divided by magnitude, which is square of this. So we get 2 square plus 1 square plus 3 square times square of this, 1 square plus 5 square plus 5 square. Okay. So that is what it is. So let's calculate their magnitudes. We have square root of 4 plus 1 plus 9, which is square root of 14. So we have, let me use different ink, minus 8 over square root of 14 times 25, 25, 50, 51. So let's calculate this. So we have 8 divided by, within brackets, square root of 14 times 51. Okay, so wait. So we'll go like this, equals to. So that gives you 0.29939. And from here, we can find what the angle is, correct? Okay, so I hope you can see it. Let me push the page a bit in. Okay, that should be fine. Okay, so we'll say theta is equals to cos inverse of this negative number, which is negative, right? So we'll do cos inverse of this negative number, which is minus 0.29939. So we get an obtuse angle here. Well, I just placed in, let me write minus times answer. So we get a negative number. We'll do shift cos inverse of our answer. That gives you the obtuse angle, and the obtuse angle which we get here is 107.42. We are looking for acute angle, right? So the question here is acute angle. So whenever you have lines, right, so you could get both. So we basically are interested in this angle, the acute angle, which is going to be 180 minus 107.43. So we'll take away this from 180 and we get 72.57, let's say 6 degrees as the answer. So that is how you can find the angle between the two lines. Now other parts, part C, we'll do in the next page. Now we need to find intersection of these two lines. So let's get back to our question. The equation was given in this form, right? So we need to find intersection of these lines. So we can write line 1 as x equals to 2t plus 7. So we can say x equals to 2t plus 7. Y equals to, writing this as equal to t, right? So y equals to t plus 2 and z equals to minus 3t minus 6, right? For the other equation, the values are already given to us. So line 2, we are given x equals to 3 plus s, y equals to 9 plus 5s, and z is equal to 13 plus 5s. Okay. Now, let's try to find the point of intersection. So to find the point of intersection, we'll just equate these to be equal and try to solve those simultaneous equations. So what we get here is 2t plus 7 equals to 3 plus s, or 2t minus s equals to minus 4. Okay? So this is from equating x values. Now let's equate y values. So we get t plus 2 equals to 9 plus 5s. So we get t minus 5s equals to 7. So that is after equating the y values. These two equations can be solved. So we can say from here s is equal to 2t plus 4. Substitute this s here, right? So we get t. So we are substituting this value of s right there. Okay? So we get t minus 5 times 2t plus 4 equals to 7. So t minus 10t minus 20 equals to 7. And that gives us minus 9t equals 2. We'll take it on this side, so it becomes 27. And that gives you the value of t as equal to minus 3. Okay? So we get t as minus 3 here. So we'll substitute t as minus 3 and get x, y, and z. Correct? Okay. So if t equals to minus 3, in that case, the point of intersection is x equals to 2 times minus 3 plus 7, which is minus 6 plus 7 is 1. Y equals to minus 3 plus 2, which is minus 1, and z equals to minus minus, let me write here, minus 3 times minus 3, which is minus is 9, minus 6. So 3 times 3 is 9, 9 minus 6 is 3. So the point is 1 minus 1 and 3. Correct? Now you should verify from line L2 also, right? So we do get a point here, which is 1 minus 1, 3. So let's check using line L2. So sometimes we could have skew lines, correct? That is the whole concept. So let's check. So we get x equal to, when I write minus 3 here, I do get, now we have actually found t, so that is fine. To find s, we will write s equals to, okay. So s is 2t plus 5, so that means s equals to 2 times minus 3 plus 4, which is minus 6 plus 4 as minus 2, okay? So s is minus 2 for us. So the x value will be 3 minus 2, which is 1. The y value, substituting s equals to minus 2, so we'll write here, line 2, s equals to minus 2. Is it okay? So I'm directly substituting minus 2 here and then calculating. So when I substitute 5 times minus 2, we get minus 10, and 9 minus 10 is minus 1. In this case, minus 2 gives you minus 10 once again. 13 minus 10 is 3. So we get the same point, right? So we get the same point, 1 minus 1, 3. So since it is the same point, we say point of intersection is, so point of intersection is, okay, is 1 minus 1, 3. Okay, so that is the point of intersection. Now let's move on and take question number 11. A line L1 passes through the point A, which is 0, 1, and 8, and B, which is 3, 5, 2. Determine vector equation of this particular line. So we could use any one point and find the direction, correct? And write down the vector equation. Okay, so let's find the direction AB first. So AB is equal to, let me write here, 3 minus 0, 5 minus 1, and 2 minus 8, which is 3. 5 minus 1 is 4, 2 minus 8 is minus 6. So that is the direction AB, and therefore the line R could be written as, the point we could take 0, 1, 8, right, plus t times this vector 3, 4, 6. Perfect. So that is how 3, 4 minus 6, I'm sorry, we can get our vector equation of the given line. Now the second equation here is, the second line L2 has this equation, 1, 13 minus 14, s times p01. Given L1 and L2 are perpendicular, determine the value of p. So we have to find the value of p now. We are given that L1 is perpendicular to L2. That means they are direction vectors, right? So that basically means that m1 dot m2 equals to 0. That should help. So the direction vector here is 3. So let's say 3, we can write like this, 3, 4, minus 6 dot. For this we have p01, right? 0 equals to this. Let's do the dot product. So we get this as equal to 3p, that is 0, minus 6. And so solving, we get here 6 equals to 3p, and that gives you p equals to 2. So we get the value of p as 2, correct? So the second line L2 we can write here is basically 113 minus 14 plus s 2, 0, and 1. Okay, so that becomes line 2. Part C, the lines L1 and L2 intersect at this point, determine Z. And then we have other two questions. So we can take them up in the next page. Okay, so let's take CDE in the next page. Now let's find the point of intersection C for the two lines. So let me copy the equation for the two lines which we just found. For L1, we had 2 points, and we got the equation as 0, 1, 8 plus t times 3, 4 minus 6, right? And for L2, the equation was 113 minus 14 minus 14 plus s times 201. Okay. Now the question says line L1 and L2 intersect at C, which is 3, 13 and Z. Right? It already gives us a point of intersection, right? So point of intersection is C, which is 9, 13 and Z is already given. So that means this point is common to both. So what we can do here is find t from the first line, substitute and get z, right? So from the first line, x equals to 0 plus 3t. We know x is equals to 9. So 9 equals to 0 plus 3t. So that means t equals to 9 by 3, which is 3. So we know t is 3. Since we know t is 3, we can actually substitute for z. So for z, we know that equals to 8 minus 60, right? And since we know t is 3, we can find this point. So t equals to 3, so we'll just substitute. So we get z equals to 8 minus 6 times 3. So we get 8 minus 18, so we get minus 10. So we get z as minus 10. And therefore we have point C as 9, 13 and minus 10. Does make sense to you? Correct? Now, you could do this with the second line also, just to verify. Now, in this particular case, since we are given that they intersect, so we don't have to verify. Does make sense? So let's move on and do 11D. We're almost at the end. Question number 11, the last question, part D and E. We need to determine the point D on L2, which is square root 5 units from C. So let's copy the value of C which we got. Point C we got as 9, 13 minus 10, right? And the line L2 for us is 113 minus 14 plus s times 201. Correct? So that is the line. Now we need to find a point D on L2. So the point D is on this line. So D is on L2. So that the distance CD, the magnitude of this is square root of 5, right? So that is the question for you. So let's see how to figure this out. Now we also have part E where we'll find area of this triangle ACD. Okay. So let's do the first part. So let's first find the vector CD, C to D, right? So let's find CD first. CD will be any general point here is 1 plus 2s. So we have 1 plus 2s minus 9. Okay. Then we have 13 plus zeros, that is 13 minus 13. And then we have minus 14 plus s minus becomes plus 10. Correct? So that is CD, which is 2s minus 8. This is 0 and this is s minus 4. Correct? So that is what we get. So now we need to find the magnitude of this square root 15. So the magnitude will be, so we get magnitude of 5, right? Magnitude of 5 is equal to square root of this square, which is 2s minus 8 whole square plus 0 square plus s minus 4 whole square, correct? Which is, We can square both sides. We get 5 equals 2. Now we'll expand. So we get 4s square minus 4 times 2, 32s, plus 64, plus 5 minus 1 is 1, so which is 1, correct? So we can bring this on the other side. So we get 4s square minus 32s. And here, if we take away 1 from 65, we get plus 60. We can take 4 common, right? S square minus 8s plus 4 times 120 is 15. We can factor this. We get 0 times s. Now 15 is 5 times 3, right? Both negative. So minus 3 times minus 5. S minus 5. So that gives you two values of s. So s could be 3 or s could be equal to 5. So these are the two values of s which will give you the point D, right? So using these two values, we get two different points. It makes sense. It could be on either side, right? So let's find these points now. So for s equals to 3, here, the point is on L2. So for s equals to 3, we have x value as equal to 1. 3 times 2 is 6, right? So 3 times 2 is 6, 6 plus 1 is 7, and y value is 13, and z value is taking away minus 14 and 3, which gives us minus 11, right? So that is one value. To take 5 as s, if I take s equals to 5, in that case, 5 times 2 is 10 and 1, 11. So we get x equals to 11, y equals to 13, and z equals to, s is 5, so we get minus 9 as our z value. So those are the 2 points for D, right? So we get D as, so we know the point D could be 7, 13 and minus 11, or D could be 11, 13 minus 9. Is that clear? So that is how you can get the value of D. Now let's do part E, which is determine area of ACD. Perfect. So the triangle ACD, where we are given the point A, okay, let's get back to our question. In part A, we are given point A, right? So here is the question. Now, a line L1 passes through point A and B, and then we know that L2 is perpendicular to L1, right? So what we have here, basically a situation that we have two lines, so one and the other one is kind of like this, right? So these are the two lines. Now they intersect, L1 and L2 intersect as C. So C is 9, 13, Z, right? So they intersect at this point, which is C. Correct? So A, let us say this line is L1, and let's call this point as A. Coordinates of A were given to us as 0, 1, and 8. Correct? Now coordinates of D is on L2. So let's say this is coordinates of D, and the coordinates of D are, you could use any one of them. So let's say 7, 13, and minus 11. Is it okay? So we are using one of them on this side, let us say. So the triangle formed is right there. We are given that CD is square root 5. We are given this distance is square root 5. Now we need to find area of the triangle, correct? So to find area of triangle, we know here we have a right triangle. Point C is known to us as, this is our point C. So we can find AC, multiply, and then times by half, correct? That should give us the result. So let's find AC first. The magnitude of AC will be, I'm just squeezing it here, square root of, C is 9, 9 minus 0 is 9 square, so write 9 square, plus 1 minus 13, which is 12 square, plus 8 minus 10, which is 18, so 18 square, correct. So let's do this. So we have square root of 9 square plus 12 square plus 18 square, which is 3 square root 61, correct? So we just found AC. So we are doing it in short. I hope things are clear, right? So area of triangle is equals to half of AC magnitude times CD magnitude. So we found this to be 3 square root 61. The other one is given to us as square root 5. So we'll just multiply the result by square root 5, right? And then divide it by 2 to get our answer in, let's say, decimals, which is 26 point, let's say, 2. Okay, so that is how we find the area, which comes to 26.2. So we did part E in short here. So we can write down the area is approximately 26.2 units square. Is that clear to you? Perfect. So that is how we could actually solve all these questions. I hope your concepts are now absolutely clear, and this test paper really helps you to solve questions relating to lines, velocity, displacement, angle between lines, distance from a point, and area of a triangle. Perfect. Hope that helps. Feel free to write your comment, share your views, and share my videos with your friends. Share your questions. Thanks for watching, and all the best.